today's topic is going to be how to get into multi-million-dollar companies. So that's a spicy title, but like, what does it actually mean? So first, I'm going to give you a safety warning. Some of this stuff might get you arrested if you do not have written express permission from the company that you're trying to get on. A lot of these techniques, I'm going to like talk about how to do them, but I'm not really going to like tell you how to be quiet when you do it or like how to be careful about it. So a lot of these things, if anybody has any like $1,000 intrusion detection system on their network, then they're probably going to see that you're coming. So, and they'll probably know exactly who you are. So don't try it at home. So what are we doing? We're going to figure out how to get into these companies using a variety of techniques like social engineering. We're going to talk about exploitation, mostly social engineering stuff, because you actually don't need a lot of fancy exploits to get into most of these companies. Then we're going to talk about what you are able to do once you get in. You can do more social engineering, or you can start slinging exploits at people. And then you can talk about, and then we're going to talk about how to move around and how to go get more privileges than we started with once we're in there. So the basic framework that we use in security for this kind of thing is called a penetration test. So a penetration test is this process that I'll talk about in a second, but basically this is when a company gets hired to try to get into a company, this is kind of what you do. So the first stuff that you do here is reconnaissance. Reconnaissance is trying to go figure out like what the game is, what it is you're looking at. So that might be like figuring out what all the subdomains are, or figuring out like what all the domains that this company has, or maybe it's figuring out who the CEO is, who the CISO is, who it is you might want to try to social engineer. The next part is enumeration. And this is really like trying to get an idea of what your attack surface is. So this might be things like if you see a web server, trying to go figure out what the web server looks like, trying to go figure out what vulnerabilities might exist in these places. Usually reconnaissance, or usually enumeration is a lot more active and you're like probing all of the servers and you're poking around. Whereas reconnaissance uses a lot more Googling and like looking at GitHub and that kind of stuff. So the next part is exploitation, which is, I think, sort of self-explanatory. This is when you're actually putting the exploits in, you're actually doing the attacks. And then post-exploitation is just a repeat of doing exploitation as you start escalating your privileges once you're into the network. And then cleanup is kind of lame. It's like just making sure that you covered all your tracks. And a lot of the time for formal penetration testing, it's just writing the report and telling everybody what you have found. So there's two types of hacking that we can use to get into these companies. You can hack the technology, which is all this exploits and this vulnerabilities and a lot of the stuff that we talked about in the Tuesday meeting with all the CTF stuff. But it's a lot easier to just hack the people using phishing and open source intelligence, because a lot of the time programmers are very good at writing good technology, but they're really dumb when they get an email or they get a Slack message or something. So really what you're looking for, and the reason you go for the people rather than the technology first, is that you want to breach the security in the easiest way possible. The official security term for this is the path of least resistance. So basically this motivates the majority of this talk, which is about hacking the people. There's a fence and there's obviously a path around it because people don't like the fence. So everybody just walked through the grass and decided that they didn't want to jump over the fence. So the first thing that you can look at is physical security. So what if you're on the premise? Well, there's a lot of things wrong with this picture right here. For example, or I guess maybe a personal story, is if I look out the window or on the balcony of my apartment, I can see the window of NCR and people's computer screens are facing the window. So if I really wanted to, I could get a pair of binoculars and just watch the person, probably, higher floor. So he's probably a more high level employee. And eventually you can just get their password or start reading their emails and like figure all this stuff out. So when you have physical access or when you're nearby to one of these places, you have a lot more tricks up your sleeve that you can use. So the first thing that you can do is you can start cloning a badge. One thing that you can really take advantage of with employees of companies is that they love bragging about where they work. So, and we'll revisit that in a couple minutes as well. So if you just Google Facebook employee badge, you get all these pictures of badges. You don't even get just like, you get Microsoft ones, you get Apple ones. Like it's not even just Facebook. People love doing this so much. If you really want to start doing it, you could also start looking at LinkedIn. People are like, oh, I'm beyond excited to start working at Facebook, and they post all of that stuff on their LinkedIn. So you can go print out one of these badges and you can just walk right into the building with the badge oftentimes. And then somebody will see you and you tailgate them through the door and then you're all good. But if tailgating doesn't work, then you can start cloning the badges. So these are some RFID cloners. Basically, what happens is that your badge, same with your buzz card, has an RFID chip inside it, which means that when you walk up to a sensor, it's going to let you in or not let you in based on the data that's on your card. So these start at about $7. These don't work very well for $7, but it gets up to like $300 for one. This really powerful one that you can like put in your backpack, and then you can just walk by somebody, or you can put something in your pocket, brush by somebody, and you've just cloned their card. So now you really can start having some fun, because now you have a badge that has your face on it and the Facebook logo, and you have a badge that lets you in. They're probably not going to cross-check the image that pops up with the badge image. So now you're in the building. So that's kind of like physical security and how to get in there. When I worked at a company a couple years ago as an intern, they were telling me that this person once, without even having a badge, just walked into the office, tailgated somebody up into the like 17th floor of the building. And then he proceeded to start trying to take the iPad. They had these little meeting rooms, and each of the meeting rooms had iPads that told you, it's kind of like the Colk. And people started trying to take the iPads and leave the building. And they were able to get away with it for like, it was like 15 minutes before somebody asked them to leave, which I thought was a while for that. So that's like physical, just brute force trying to steal stuff. But we can get a little more technical and get a little more higher results here. So we're going to talk a little bit about Wi-Fi security. So usually when it comes to Wi-Fi security, it's a lot better to have Ethernet in your computer than it is to be over Wi-Fi. And this is kind of why. So what somebody can do, and they sell $100 devices that will allow you to do this very easily, is you go to the office and you put up a fake access point. Say you call it GT Wi-Fi, or maybe you do like GT Wi-Fi period, something that's different than the Wi-Fis that already exist. And now you control the router that is controlling all the network traffic, basically. So you get to decide what, it's like if somebody types in google.com, the punchline is that you're going to be able to determine what google.com brings you to. So you can make something that's very convincing that looks like it's google.com, but it's really not. There's a bunch of other stuff you can do as well, because you're also allowed to look at all of the traffic that's going over the network. So a lot of the time that's going to be encrypted, but if it's not, then you're in business. And in order to do all this stuff, all you need to do is broadcast louder than the actual access point, which is very helpful when you're just close to the person that you're trying to attack. Because there's kind of an inverse squared law when it comes to access points. So if you're just a lot closer, you're going to quadratically be better than the actual access point, which, in layman's terms, that it's just, you got to get close to them. So when I was in high school, they let me do a cybersecurity demo for my computer science class my senior year. So I decided to do this as the demo, basically. So I got, I had permission, express written permission and all that stuff, put up the access point, and I was like, hey, connect to my access point. All the while I was like projecting this tool that just starts dumping people's passwords as it starts detecting them on the whiteboard, on the smart board. So people start connecting to it. And then we found out that the school's website had an endpoint on it that did not use HTTPS. So we just started dumping passwords of like all the people in the class onto the whiteboard. So I got the plug pulled in my demo, but it was still very funny. But you can, yeah. So anyway, if you're on the Wi-Fi, this is a little more like of a technical dive into what it is supposed to happen and what can happen when you are on the Wi-Fi with them. So maybe disregard the daemon for a second. And so what's supposed to happen when you go to a website is, this is a simplified model of it. Your computer is going to say, show me google.com, and it's going to send that off to the Google server, and then the Google server is going to give you google.com. Does that make sense? So what happens in the case of somebody either owning the router is a really good way to do it. And you can also, there's some ways to do it even if you're not the owner of the router. If you're just on the network, you can basically start announcing to everybody on the network that you are the router, even if you're not the router. And then you can start doing the same kind of tricks. That's a lot noisier though, and you'll probably get detected and kicked off the network if you try to do that on an enterprise. So basically what you're doing is somebody's going to start saying, show me google.com. And now you're the one who's receiving the request. And so you can say, okay, yeah, you can just basically be a proxy in the middle, and you can reach out to the actual Google server and say, show me google.com. And then Google comes back to you, and then you send it back to the client at the end of it. So you can actually modify what google.com looks like over the wire doing this, or over the air. So that's fun. One time on the school Wi-Fi in high school, I just like made it change the background color of some like various websites that did not have HTTPS on it. So it'd be like a pink background, and people would go to it and just didn't know what was happening. So you can't. Oh, by the way, that's why you use HTTPS. Like that's the #1 reason that like HTTPS, the little green lock up in your address bar, is a thing, because that prevents you from doing this. But even if you're using HTTPS, you can just get a little bit, you can just change your attack slightly and basically do the same thing, but now you're just getting a different part. So is everybody, who's familiar with like DNS? Like, let's go like a show of hands. Good, so most people. So I'll give like a quick overview of what's happening here. So basically on a network, when your computer actually wants to talk to the Google server, it needs an IP address to go figure out where Google is on the network. But it's really hard to remember IP addresses. So there's this whole other service called DNS that will take a domain name, say google.com, and then it will translate it into an IP address. And the server that figures out the mapping between google.com and the IP address is a separate server from Google's web server here. So the punchline here is that while the Google server might have HTTPS on it and you can't intercept the traffic, you can prevent the client from going to the Google server in the first place. So basically what you do is, like I said, if you're on the network like this, you control what the IP address is. And if you're the router, you can actually just set what the DNS server for your network is. So basically, you can make the client ask you what Google's IP address is, and then you can feed them the wrong answer. And then I guess I should put this in here. So then you can, so you're asking the compromised DNS server and it's coming back, and now you're going to the bad web server that's not controlled by Google. And all you have to do is say something like, you just make it look like Google, and they're completely fooled by it. Does that make sense? Cool. And by the way, there's some like ways to, there's some things that your browser will do to get around this. Like for Google, like a lot of websites this works for, but for Google, they have a, basically they have a list that's built into your browser the first time you go to the Google website that says what Google is supposed to be. So if it tries to be anything, if Google tries to resolve to anything but their list of IP addresses, it just won't let you get on the website, which is why you get like a, sometimes when you connect to an internet that has like a captive portal on it, like at a hotel, you might get some errors when you try to go to Google, which is why that's happening. Because basically what your hotel Wi-Fi is trying to do is it's trying to go basically act like the bad DNS server right here. And it's trying to bring you to their portal where they're going to make you pay $40 a day for internet instead of going to the place that you're trying to go. So they're basically doing this to keep you captive. So another way you can do it is, another way you can break into companies is social engineering. And so I don't have a demo of this, but I do have a cool video from the winner of the DEF CON social engineering CTF from a couple years ago. So there's this a cybersecurity conference called DEF CON that happens in Las Vegas every year. They've done it like 30 years in a row now. And every year they have a social engineering village where a couple months prior to the event, they'll say what the company is going to be that you're going to try to get into. And so people will go and spend like hours and hours trying to figure out everybody who works at the company, who the best person to talk to at the company is. And then during the actual convention, you get on stage and they tell you, okay, you need to go figure out what the lunch menu at this company is. So hopefully you know who it is you need to talk to figure out what the lunch menu is and what you need to say to that person. They'll have stuff like that. They'll try to ask you like what version of the operating system you have on your computer. So people will act like they're the IT department. So hopefully the sound works here. So that's really effective. And it's so impressive watching these people at DEF CON do this, by the way. Like they get up there and they just totally have these people on the hook. I saw there's this other video that I used to show, but I thought this one's funnier because they have the baby crying, where he calls the company up. This guy named Kevin Mitnick. He's a super famous, like he writes books. I think he did the like cybersecurity training I had to take as a Georgia Tech employee, and it's like him doing the whole thing. And he goes and he calls this person who works at this company. This is on stage at DEF CON, by the way. He calls the company guy. He says he's the IT person. He's like trying to go get this, or he says he works in HR and he's trying to get this guy's benefits to put together for him. So he calls him and totally has him on the hook. So like, hey, can you go to this website and just hit run when the thing downloads? And then on one of the screens behind him, he has a terminal pulled up, and then he goes and he runs the program, and you see his like remote access to the computer pop up on the screen behind him. It's very interesting how this stuff works. And it's also like, if someone really wants to get you and they know all this stuff about you, like they could probably just get you. Like if, for example, if somebody like was trying to get me, they could go and they could email me and they say, hey, I'm the president of the cybersecurity club at Clemson or something. Can we get on a Zoom call? Then you start like building trust with the person, and then they ask you to do something and they pounce on you, and then you're just screwed because you trust them. So you can watch it again. So I think we kind of talked about this Georgia Tech example during the previous meeting, but my story here is that I used to work in the Georgia Tech Security Operations Center, and one time, this is probably 4 years ago now, somebody sent out a phishing email that had a carbon copy of this website right here. And the nasty trick that they had is that when you would type in your username and your password, it would redirect you to your actual Outlook page. So it looked like it just logged you in, nothing went wrong. But then it would actually send it to their server. So within about 30 minutes, I think they got like 30 or 40 professors to do this. There was a targeted attack on the aerospace department, and they did it. So I had to go call people for the rest of the day and reset their passwords. Because the other thing that Georgia Tech has going on is they can actually read all your emails, and they can see if you've opened the email, and they can see if you visited this website. So if you visited the website, then they know that you clicked on the phishing thing, and so they know to reset your password. So, it's bad because they can see if you're mining cryptocurrency on their Wi-Fi, but it's good because if you get hacked and you're about to go reveal government secrets, then you're not going to actually do it. So there's a couple of different ways to do this. You can do emails, like you can do phone calls like we saw. But another very effective way to take advantage of people is to use GitHub. So does everybody know what GitHub is? Can I get like a show of hands? So basically GitHub is, oh, we're gonna do something else first. My bad. So, and you may think that so when it comes to websites and phishing websites, you may think that you're safe if you have two-factor authentication turned on, right? Well, you're wrong, because what they can do is they can just put a website in the middle here. And what the website does is it basically is going to broker the two-factor authentication between you and the real server. So basically, I go to Georgia Tech and I type in my username and password, and the compromised server is going to take my username and password, and it's going to pass it off to the actual Georgia Tech server and try to log me in. So now Georgia Tech is going to say, okay, well, you know the username and password, but I also need to know your Duo code. Let's say that it's going to be a code, not the push notification for the purpose of this. But so server comes back, asks for your 6-digit code. It sends it to my server that I control. So then my server just goes and asks you what code you just got sent. And now I can just pass it back over to the server. And now I'm into your account, even though there's two-factor authentication enabled. Sometimes they get around this by like, if on Google, it'll tell you if you have a new IP address, and it will add another step of verification in. But I mean, at least for me, like usually I just assume that it's because my like IP changed, or I've just like am on the cellular network, or I'm at a coffee shop or something that's happening. So it's not very good. This is a phishing website, obviously here. I tried to set up a demo of this, but I couldn't get it to work. So it's kind of hard to do. So the other thing that you can do here is you can do some squatting. So basically, there's a couple different types of squatting, and they have varying levels of effectiveness here. So the first type is called typo squatting, and that's when you just profit off of people fat fingering or mistyping emails. So if I do like, the F is right by the G on the keyboard, if I type fugle.com, or if I type Google with one O because my key is stuck, then that's typo squatting. And that's, they're never going to know that they that was the compromised website. The next one is called combo squatting, and that's basically when you just look like a popular domain. Like if you're like googleserver.com, then that is an example of something that might have trust because the brand's name is in the domain. Another thing, and there's a lot of research in this, is called residual trust. So basically, residual trust is when you watch for when a domain is going to expire that was previously owned by a brand or by somebody who has a lot of credibility. And then as soon as that domain expires, the malicious person will register that domain, and then they'll start serving up malware from the domain that's already been trusted. And so that's really bad for it's bad for users, because if you've been to that website before, it's going to autocomplete. Maybe you already had an account on this website. But the other bad thing is that when a lot of these, like a lot of the time they have machine learning models that will go and try to figure out if a domain is bad or not. And one of the ways it does that is it looks for like the word Google inside your domain. And if it's not pointing to a Google address, then it's going to tell you that it's a bad domain, it's a malicious domain. But if you have something like, if you are re-registering a domain that just expired, then like very recently prior to you using it maliciously, it's going to have pointed to a Google domain. And so that kind of model is not going to work. That's going to try to determine what the reputation of the domain is. Does that make sense? Cool. So the other thing besides domain squatting, this is another like kind of recent thing that's become a huge problem, is that when you're doing like npm install or you're like installing a package in your terminal, people will go and squat on those too. And those are actually really nice because those will always run as code on your computer. So you don't even have to go download anything. You just assume that it's going to work. You import it into your app.js file and then you're screwed. So two examples that I saw when I was looking this up is there's a Python library called dateutil. And so the funny thing about this is that if you go to the pip website and you type dateutil, this also pops up. So now you got to go make sure you're picking dateutil, not Python 3-dateutil that actually has malware in it. And then the same thing with like scikit-learn. Like the two ways that they get people is like either people are making typos when they're doing pip install, which I know I've done that like 20 times at least. And then people will also just try to go guess what the package name is. And if you've ever tried to go play if you've ever tried to do that, you can be really wrong about it. Like for example, like scikit-learn, I think sklearn works and scikit-learn works, but this one does not work. And then the other thing that people will do, and this one's a little bit more obscure and it's kind of a recent like field of like research in network security, is that whenever you are hosting your website on AWS or Azure or something like that, you are usually reusing an IP address that has been reused by a bunch of other people. And a lot of the time what will happen, and also these IP addresses usually are not used by you for very long. So if you have a load balancer, for example, that sits in front of your web server, so that if you get like 1 million people that start using your website one day, like AWS will automatically scale you up and they'll just say like, hey, we're going to send every user to one of these load balancers and it's going to not make your server crash. Then the next day you go back down to like 1,000 users and now you have that IP is going to no longer belong to your account and anybody else can now use that IP address. So basically what will happen, and there's research in this like being a big problem. I think it was something like 3,000 IP addresses fell to this problem. People hard code these IP addresses in their code, and then they won't realize that the cloud IP address now belongs to somebody else. So in short, like now a malicious person can go and sign up for AWS and they get assigned that same IP address. And now that person is using the IP address. It's kind of similar to the residual trust thing, but it's for IP addresses. Does that make sense? Cool. Okay, so this is my favorite thing to talk about because I've done a lot of this. So you can also get a lot of value out of looking on GitHub because developers love to go post their passwords on GitHub. And I'm going to show you some examples of that right here. So first thing that people like to post is their SSH configuration files. There's nothing too bad in here, but you can now see like this is Amazon. This is get.amazon.com. You see like gateway sfo.lifts.net. You know, that's probably shouldn't be on GitHub, but not too bad. That's the same slide. But you know, some people will post a little worse than that. Like they'll post their payment API keys for their apps on GitHub, or they'll post their OAuth tokens that shouldn't be leaked on GitHub. This one is for App Annie. Or it'll get even worse and people will start posting their employee credentials. Usually what happens is that they'll like, a developer will write a script that, for example, if they want to go pull down their emails and put it into a spreadsheet. I don't know why you would do that, but let's assume that they did. So basically they write a script, and it's a nice little nifty script that's going to go connect to their email, and it's going to download all their emails, and then it's going to go do some processing on their emails. But then they want to share that script with everybody, and they don't realize that their username and password to their email is in the script. So now it's on GitHub for everybody to go look at. And then some people think, oh shit, I just posted my API key on GitHub. And so now they make a commit that just says remove rogue API token or something like that. And now you know exactly where to look, because all you need to do is I think for this search, I just typed remove API token, and it gave me 150,000 examples of people doing this. So you see right here in the diff that the token was there and now it's gone, and it's up to you to go figure out whether that is real or not. Another class of people that really like to post things on GitHub, I don't really know why. I think it's because usually they don't have like a foundation in programming. Maybe they have a foundation in like math or something, or in software engineering rather. Is a lot of data scientists like to do. I found salespeople and data scientists do a lot of this kind of thing. But they basically go post their data science projects. This is for Lyft right here, and this is a bunch of like support emails between drivers and Lyft support. And this is a Jupyter notebook, so basically it's like Python, but it will show you in the file what the output of the Python is. And so that's the output of the Python code. Yeah, go for it.
Oh yeah, so I'm also in the agency, and a couple of years ago, you might remember this. There was like a project called like the Love Machine, where people would fill out a form, and it collected their data, and like they try to match you with people you might be interested in like meeting. And then someone said, "Hey, I have all this data. Why don't I just use it in one of my school projects?" And so they committed it into their project, and then they pushed that project publicly on GitHub. And then it became a big issue in the CSC. So yeah, the CSC will get mad.
And then they go do it too. So another thing you can go find here is like copy paste history. So this was an example of how IntelliJ a couple years ago, if you had the Vim plugin installed, whenever you copy pasted something from Vim, it would basically write the output of the copy paste buffer out to a file, I guess, so that when you closed it and opened it back up, it was still there. But as long as you know what to look for, and you know that this is base 64, you can decode it, and now you have somebody's AWS token in here. And I think this was Grubhub's AWS token, by the way. So what was I going to say about that? I forget. That ended up being a CVE, actually. That was like a exploit that somebody made some money off of, probably. So I actually made a tool that finds this kind of thing. And basically what it does is it looks for high entropy strings that are probably API keys. And then it also looks for words, for example, like AWS secret access key, and then something that looks like an access key. A really effective way you can do this is a lot of the time, the API provider will make their API keys look a certain way. So I'm going to show you an example of that, actually. So let me do that. So what am I doing? Okay, so this is GitHub. You probably knew that. Okay, so I'm gonna probably show you. I'm going to show you two demos here. So first, I'm going to try looking up corp.amazon.com, and Amazon's really bad about this, by the way. So if we sort by recently indexed here, like pretty immediately, Amazon commercial shops, logistics information. Probably not going to be any passwords in here, but it's interesting. And then you just keep like looking through, and you start finding like configuration files, and eventually if you do this long enough, you can find something interesting in here. One thing that's really useful when you're trying to do this is like this one right here gives you a list of other stuff that you can search. So like this is all like internal Amazon services, like they're all their internal subdomains here. And so you can just go and like now you have like 50 other things you can go search on GitHub, and you can see if you found something for that. So I haven't done this. So if anybody wants to try it, you might be able to make some money. And then the other way, maybe the more effective way to do this is you can like look for people who use a certain type of API key, and then you can just go see if they are see where it's being used. I call that shoot first, ask questions later. So let's try like newrelic.com, and I happen to know that New Relic API keys start with ARAK. And this one I know is going to be more interesting. So if you do that and you sort by recently indexed, yes, I can. Maybe. Oh, I know what I did. I have to like share the other. I guess this one. Right. So I know that newrelic.com, they have an API endpoint, and I know that ARAC is what all these keys are going to start with. So just to speed it up, I'm going to look up. Maybe I need the word API. Yeah, obviously I don't know how the keyboard on here works. Okay. And it's not working. This was working earlier today. I'm gonna give it like 30 more seconds then. Okay, well, trust me that sometimes you can find API keys on here. And when you do, I also have a script that is specifically like designed for this. So basically what it does is it looks up this kind of query. Usually I just look up newrelic.com, and then it will go and basically it finds the API key. It knows how long the API keys are, and also that they start with that, which is still not working. And then it's going to go and try it against the New Relic API, and it uses an endpoint that prints out who owns the API token. So then if it's like, like Bob at Lyft.net, then you know that it's a Lyft API token. You can go report it. You can make $1,000. And so that's pretty helpful. I can probably talk about that more at another date as well. So, oh my gosh, I hate technology. Okay, I think that, and then that's the wrong one. Last time I tried to do a demo. Okay, this is an example of like actual output from this. So these are some actual API keys in here. These are all the companies that I found these on. And so now we're going to talk about some more technical, like how to hack the actual systems here. So basically, the premise of what we're about to talk about is that businesses need two things. Georgia Tech has this. So whenever you log into one of these workstations right here, you log into the Edgy room, you have the same username and password. So it's some way, somehow, you need to be able, there needs to be a centralized way, that thing that stores everybody's username and passwords. Can they see the slides again on the Zoom? Okay, I'm just making sure. Cool. So then you also want to be able to do shared corporate information. Like whenever you open Outlook, you want to be able to autocomplete somebody's name and then all the information about them. So usually what people use to do this is called Active Directory. It's a Microsoft product, and it usually almost entirely it's run on a Windows server. A couple little terminology that we're going to use is a domain controller is basically that thing that is storing all the information about everybody. And then a domain administrator is someone who has access to all that information, and usually to go change the information. So Windows is a toxic hell stew of exploits. So it's about 40 million lines of code. And what they say is that you can't. Crap. Well, I think I can actually fix that relatively easily this time. Oh. Okay. Nope. Okay, on average, they've calculated that like I think it's every 10,000 lines of code, there's expected to be a security vulnerability based on like past vulnerabilities that have come out. So there's a lot of vulnerabilities in Windows. Actually, every month on the second Tuesday of the month, they release all of their Windows vulnerabilities. And pretty much every month, there's one that you just got to go update in order to fix. There's been a lot of major vulnerabilities through the years. The most famous one here is called MS0867, which for a lot of security people just rolls off the tongue because it was so bad. It was basically the vulnerability that was used for the US government and partners to hack into the Iranian centrifuges. What they did was they dropped a bunch, there was actually some social engineering and physical security that was part of it as well. They basically dropped a bunch of USB sticks in the parking lot of the centrifuge thing. Somebody plugged it into their computer. This was a completely air-gapped network, by the way, so it had no network access. They were able to get past that. So they plug it into the computer, and then it installs malware on their computer. And then the Windows exploit fired off, and it just got them into all of the machines. And eventually, they were able to find an exploit that overloaded CPUs, and it caused the centrifuges to explode. So that one was really bad. And then there was another one in 2017 that was leaked from the NSA that was similar thing, but it was for Windows 10. So it was the next version up. And then there was there's a lot of other exploits like this that affect less widespread services. But whenever you see something that affects file shares, or like Samba is the other term for the file shares, that is really bad because the file share system are how Windows computers talks to each other. It's not just for like sharing videos with other things. So that's really bad. But you can get into a lot of Windows systems with this. And like there's also a lot of other vulnerabilities that will just allow you to do privilege escalations and stuff once you're inside the network or you have a user on the network. So once you already have access to one computer, then you're a lot better off on these kind of exploits. So let's say we've gotten into the system. Now what can we do? We're going to talk about post-exploitation here. So there's a lot of different things we can do. So we can start stealing people's data. If we have access to some Active Directory stuff, we can start stealing everybody's information. Maybe we can get access to a database and we can start stealing passwords, credit card numbers, social security numbers, et cetera, et cetera. We can start installing malware so that we can go get keyloggers and then somebody logs into their bank account and you have their password now. You can install ransomware, which is going to then charge them $1 million to have all their files decrypted. Hope you have a backup. But then you can also do some other stuff that will give you an additional access to the servers. So privilege escalation is the term for doing that. And you can do this on Linux and on Windows. I'm more well versed in the Windows stuff, but basically you want to do some privilege escalation that's going to allow you to move laterally around the network. We'll talk about that in a second. But then you can do some other fun stuff called internal spear phishing. So spear phishing is when you're doing a phishing attack, but you're targeting a single person. So like if I want to go and spear phish Spencer, for example, then I'm going to go find out everything about Spencer, and then I'm going to go figure out what it is that I should say to him. But now that you're inside the network, you have access to somebody's Slack account that's in the network, and you can start doing some tricks there. You also want to keep persistence. Like you don't want it to be where they change their password or they restart their computer and you lose your access to the network. So there's this cool tool, I don't have a demo of it, called Slack Pirate, where you basically will point it at your Slack channel. And kind of similar to GitHub, people think that once they have a Slack for a company, it's all secure. So they'll start posting API keys in Slack in public channels. And then this will just go and download all those API keys. This is like one of the first things they do on a pen test when they get into an enterprise network. Another cool trick that I learned for this kind of thing, I learned this from a pen test that at a company I used to be at, is that you can actually change your Slack name to look at like somebody else. So for example, we're going to go to Joseph here. And I'm going to download his picture. And I'm going to go to my profile. I'm not. Should just share the whole screen. Okay, that should solve the problem for the rest of the thing then. Spell his name right. Is that right? It's not right, right? Okay, well, that's an important thing because once you're put my picture is his here. I'm just going to talk to Slackbot. Now you look like you're this person. So this actually is very effective. Like this is a joke, but like at the same time though, I've seen this happen in a company, and what they did was they changed it to some software engineer's name. And they like sent like a very pressing, like, I need this access to Salesforce right now. Salesforce has all the credit card information, all the customer information in it. And so it's like, oh, right away, I'll give you access to Salesforce. And they didn't really check whether it was the actual user or not. And so they ended up getting access to, I think AWS actually they got access to as well doing that. So that's very effective because people want to help you. So just let them help you. So basically, this is kind of the lateral movement part here. So once you've gotten into a system like the attacker here, it actually unlocks access to a bunch of other systems. So usually you have to deal with the firewall, so you're not able to directly get to things. But a lot of the time, corporate networks are kind of like a cream egg, where like once you get past the outside of the network, it's like very gooey and it's easy to get around once you're in there. So for example, you might have a database that doesn't have a password on it. MongoDB databases are famous for not having default passwords and just allowing anonymous access. So but they assume that you're going to put a firewall in front of it, so not everybody and their mom can get to the MongoDB. When I used to run a Minecraft server, and that actually happened to me where I had my database. I was like, no, I'm going to be so cool. I'm going to go put a MongoDB server up on my Minecraft server, and I'm going to be so woke, or not woke. I'm going to be so hipster. But anyway, I left it open to the world, and so people started. So this one person started giving themselves admin and unbanning themselves, and I couldn't figure out why. And he was benevolent at least, so I was able to like. He was just sitting there, and he was just an admin, and he wasn't doing anything. One time, he ended up griefing the server, and I don't know how I fixed it. I think he just got bored. But anyway, it was because there was no password on my Mongo database, and there was no firewall in front of it. So once you get in, it's a lot easier to get around. So there's a bunch of stuff you can do here. Like I kind of just showed you the Slack thing. Once you're on somebody's workstation that's on the Wi-Fi, you can start doing all those Wi-Fi tricks that we were talking about earlier, just like you can with being actually there. And also you can start finding API credentials in other places. Like you have access to GitHub Enterprise now. You have access to all their internal GitHub repositories, where people have a lot more trust that no one's going to steal their API keys, because they don't assume that there's a compromised person on the network. So now you can just get all this stuff. You're basically like, if somebody gets into the network, like 9 out of 10 times, like they're going to get your AWS tokens. They're just going to get everything, and it's going to be a mess. So another thing that you can do, and this is another Windows-based attack here, but this is very hard to detect from a network perspective. So this is called passing the hash, or passing the ticket is usually what it's called now. So basic story is that when you are Bob and you're trying to go connect to the database, maybe you need to go do some management stuff. Maybe it's probably what it is. You need to do some management stuff. Then you're going to ask the domain controller for a ticket, and that ticket is going to grant you access to the HR database. So just like Bob has a ticket that will allow him to have access to the HR database, let's say for a week, without having to go type his password in again, Alice also has a ticket that allows her to get into the domain controller. Alice is a domain admin, so she has a lot higher privilege than Bob on the network. So she is basically the end target of the attacker. So Bob is going to get compromised here. And now the HR database is also compromised because this ticket is being stored on Bob's computer for a week, right? Does that make sense? So HR database is now compromised, as well as the computer. And a lot of the time, companies like don't want you to have to keep typing your password because it's a convenience thing, and they just won't let tickets expire. So as long as the ticket is on the computer, if you have access to the computer, you can just go and mimic this user basically. Okay, so everything's going well. It's a contained attack. They don't have access to the domain controller, but now Alice needs to go run updates on the HR machine. So Alice is going to generate a ticket that allows her to get onto the HR machine. but the HR machine is already compromised. So now a ticket has been sent to the HR machine. And basically what's able to happen is that Bob, the attacker that's controlling Bob's account right now, is able to steal Alice's ticket. And now because Alice has previous access to the domain controller, I'm pointing to nothing. Because Alice has access to the domain controller, Bob also now has access to the domain controller, and the domain controller is just completely broken now. That's not something that you want. And like I said, this is very difficult to detect because you don't know what the difference. Well, it's easy to detect. You can just say that like every single connection from Bob's computer to the HR database is malicious would be the easiest way to detect it. Or you could like say if Bob usually connects to the HR database at 6 a.m. on Monday through Friday. So if I get one that's at 11 p.m. on a Saturday, then that is bad. But what ends up happening if you do that, especially if you are at a company that has like 1,000 people at it, is you get so many false positives that you don't even know what to look at anymore. So that's called alert fatigue. And you basically it's like having too much data is like having no data at all in this case. So in this particular case, you might actually have some luck with, you might be able to figure out that Bob is like, you basically could probably detect that the HR database should not be connecting to the domain controller. And you might get some like leeway on detection that way, but you would probably not be able to detect the attacker taking over the HR database. That makes sense? I know this is like kind of a technical like Windows thing. And this is all this like passing the hash and the ticket stuff, like all the mechanisms behind that are pretty like intensive. Okay, so then you're on the domain controller and you've basically found the keys to the kingdom. Every time you read something about Active Directory, it describes the domain controller as the keys to the kingdom. So if you have that, then now you can start using your privilege escalation exploits. You can start doing all sorts of stuff. And you can generate this thing called a golden ticket. And a golden ticket gives you full network access. So you can just completely like cause problems on the network now. Oh, and then another thing, as kind of an aside, another thing that you can use to find this path from where you currently are to where you want to be is there's tools that'll do this for you. That'll just download the entirety of Active Directory that has all this information in it, and all the relationships between different computers and users and servers. It even will start looking at like Azure instances, and you can just see like what your shortest path to the domain controller. It's like a shortest path algorithm, like literally. And then you can just go figure out how to get to the domain controller. So like this one, for example, like if you compromise this user up here that doesn't have a name, who's an admin on this computer, but the administrator, this is basically saying the same thing as the diagram I showed in the previous thing. Like there's a member up here who has admin on the computer one, and then this other guy who's an admin on the domain controller has connected to that computer. So now you're able to steal his ticket out of the memory and you're able to connect to another computer. And then it gets a little more complicated as well when you have a bigger network. So now you're just like, now you can just completely take over the company. So you can generate this golden ticket. You can turn off all the auditing policies. Like hopefully you're not able to start deleting backups. You can install keyloggers. You can inject code into the pipeline. That's what ended up happening in the SolarWinds attack, is they were able to go inject code into. So SolarWinds is a company that creates software that's primarily used by governments and very high risk organizations. And so they were able to get into the network, and then they were able to inject code into the pipeline that generated the software that they end up pushing out to their clients. And so they were able to compromise all of not only the company, but all the company's clients, because the software now had a vulnerability in it. You can read and send emails, encrypt everything. You can just destroy everything. It's not good. Hopefully you don't do that. And so that's the end of the talk. Hopefully you're more optimistic about security after all that. And these are some resources if you want to like learn more about this, like Active Directory, this pass the hash stuff, and really like all this stuff that we talked about. So Hack the Box is a really good one. Hack the Box basically is a website where you connect to a VPN server and it gives you access to like a Windows network, or it gives you access to Linux boxes, a whole bunch of different stuff. It's a little different than a CTF because usually these are more like pen testing than CTFs, whereas CTFs are more exploitation. And then there's also some books that will walk you through how to do stuff. And usually the books will give you a virtual machine that you can go walk through all the stuff on. So are there any questions? I've also got the winners of the Moe's gift card. So hopefully at least one person is here. You don't have to be here to win it. So okay, so it's the three are Madeline, 7